So hello everyone. Today I'm here to talk about Kotlin and more specifically how to use Kotlin on Apple devices. So most likely iOS and macOS. A few words about myself. My name is Martin, I already said it. You can find me on Twitter under the handle Martin Bonnin. I work for a company called Apollo that does everything GraphQL. And I'm the maintainer of this project called Apollo Android, which is an Android client for GraphQL. The name is a bit misleading, though, because since the beginning of this year, Apollo Android also supports iOS, thanks to Kotlin native. So this is what brought me to Apple devices. And what brought me to Apple devices is that I'm a Hearthstone player. Hearthstone is a card game that, well, it's an online card game. You can look it up online. It's made by Blizzard. And there's a nice companion app for macOS that's called HS Tracker that allows you to track your games and improve your gameplay. And I started contributing there and starting doing it with Kotlin because this is a language I knew. And so this is how I got into iOS and macOS development. So this talk really is going to be about how to use Kotlin in places where it's not always designed for. I'm just going to look at the chat because I cannot see the chat on my phone, but it looks like everything is okay. Let me know if everything is not okay. I feel like each and every Kotlin presentation should start with this slide. I actually made this exact presentation at FrenchKit earlier this year and put this slide. And since then, I realized that, well, maybe 50% of the Kotlin presentation have it. So it looks like it was not a super original idea, but I think it describes well where Kotlin comes from. It comes from this small island in the Baltic Sea next to St. Petersburg. And considering the fact that Java comes from a big island in Indonesia, it's a very warm island in Indonesia in the southern hemisphere. Having Kotlin like complementary, so it's still an island, but it's also very different. It's cold and it's in the Baltic Sea. I think it kind of makes sense. Of course, there's a reason it's in the Baltic Sea and people chose that name is that St. Petersburg is the hometown of a company called JetBrains that does IDEs and that wants developers to use Kotlin. It's also a very famous brand of Polish ketchup. I feel like not as many people know that, but it is. But this has nothing to do with the language. When it comes to the language, Kotlin has most of the features you would expect from a modern language. It's object-oriented with a lot of functional traits. So you have function types. There's a big focus on immutability, type inference, of course, which allows the compiler to do a lot of stuff that you would otherwise have to do as a developer. So I like this feature of Kotlin to not have to worry as much about declaring my variables. Of course, it tries to fix the $1 million mistake of null pointer exceptions. So if you're coding, if you're taking care, I mean, it's not like null pointer exceptions are completely out of the question, but if you pay attention, they should be a lot less frequent. It has a nice standard lib with a lot of streams and collection and a lot of stuff. And of course, coroutines, which is the latest addition, which is very nice to handle concurrency and multi-threading, but more on that later. And this talk is going to be in two parts. So the first one is going to be, and then the main one is going to be about Kotlin native, but we will see also that there are usages of Kotlin JVM and using the JVM on macOS and iOS. Well, mostly macOS. And to talk about Kotlin native, I wanted to start with this, well, very old, actually not that super old picture of one of the early computers. you might have recognized the machine that Alan Turing built to crack the Enigma code in World War II. So it was something like, let me do the math, 70 years ago now, which is old in the times of computer science, but not that old in the grand scheme of things. And when we talk computers, we're always talking about the same thing. So this is a very rudimentary computer, but the modern ones are no different, and it's always the same thing about executing a list of instructions on some program memory. And whatever you do with TypeScript, whatever your language, Swift, Dart, Kotlin, it's always going to be the same thing. So there's no reason that you shouldn't be allowed to use Kotlin native or any other language on your favorite device, which is a very sophisticated Turing machine. So when we talk Kotlin, usually we think about Kotlin for the JVM, because this is where it comes from. You take your Kotlin file, you compile it to JVM bytecode, and this goes through a JVM, which outputs a series of instructions for your CPU, which is your Turing machine. Android actually took that a bit further because it uses something called AOT for ahead of time. So instead of interpreting your bytecode, Android will compile your bytecode. So when you install an app, it takes a bit of time. And what's happening behind the scenes is that the Android runtimes take your APK, take your app bundle, and compiles it for your exact mobile phone. So if you have an ARM phone, it's going to compile down all your bytecode in one go to your ARM instruction set. So this happens on the device. And if it happens on the device, we could also do it way ahead of time and do it on the developer machine. And this is what Kotlin native does. Instead of interpreting the Java bytecode, instead of compiling ahead of time, I mean, it's compiling ahead of time, but way ahead of time, it's compiling when you build your app. It's in that way somewhat similar to what GraalVM does, except it doesn't require any of the JVM runtime or extension. So it's pure Kotlin, has nothing to do with Java. So when you look at Kotlin, Kotlin is it's a project that lives in a separate repo from the main repo, and it's a compiler backend for Kotlin that target LLVM. So it's not a compiler backend for LLVM, because compiler backend for LLVM would be architecture specific. So it's two compilers. I know it's a bit confusing, but the complete Kotlin compiler outputs LLVM intermediate representation, and this goes into LLVM and gets compiled to machine code. It's also a runtime because Kotlin is a modern language with a lot of additional constructs that you cannot represent in pure ARM instruction, for an example. So there is a runtime for handling everything object-oriented, like interfaces, inheritance, whatever you name it. Also exceptions, threads, and memory management, because obviously memory management is a lot of what Turing machines do in the end. Kotlin native interops with C. It's bidirectional, so you can call Kotlin from C, and the other way around, you can also call C from Kotlin. There's a very nice document in the Kotlin native repo explaining all the details. Of course, since C is a very low-level language, and Kotlin is a high-level language, when you bring C to Kotlin, you also bring a lot of the complexity of C. So everything I put there, like C pointer, C variable, C value ref, it's quite hairy, and it can become quite complicated to represent all the different native types. But the important thing is that it's working. It can also do memory allocation, so native memory allocation for you. So here on the right, this is an example of Kotlin calling a very low-level libc stat function and allocating memory, native memory. So this is working. I'm not spending more time there because it's also a bit complicated, and this is not what we want. Like, we want Swift, right, for developing on iOS and macOS. We love writing Swift, and the thing is, Swift is relatively similar to Kotlin. If you've taken a look at the languages, you will see they are really similar, like there are a few syntactical differences, but all the concepts really map very well. So you have null safety, optionals, functional, protocols, interfaces. So there should be a way to do that, right? And the bad news is that Kotlin doesn't interop with Swift, which makes us quite sad. The good news is it interops with Objective-C, which is cool. And if you look at what Kotlin produced for Objective-C, you look at the header files, you will see a lot of stuff like this. So it's all Objective-C behind the curtains with all the Swift annotation, which I am very grateful for. So instead of having to call all my Objective-C types, the Kotlin compiler will annotate with stuff that makes it easier to call from Swift. So Swift interop is working, but behind the curtains, it's all Objective-C. Nevertheless, all the concepts map really well, and if you have a class in Kotlin, it's going to end up as a class in Swift. Protocols in Swift will map to interfaces in Kotlin. All the native types, like strings, integer, whatever, they map really well. The list and dictionaries are there as well. Even lambdas, you can define lambdas in Swift and have them in Kotlin. Enums will also work. Of course, there is stuff that doesn't work because even if this is all Turing machines and in the end, it's all the same thing, some language have some constructs that are a bit different. So Swift has value types, for an example, and Kotlin has not. So you will not be able to do that in Kotlin. Kotlin has sealed classes which do not map really well to Swift types. So this is not possible. If I take back my diagram and I call the Kotlin compiler that generate my LLVM intermediate representation, and then that goes through LLVM, and that produces some machine code. If I want to use it in the end, I need something to import in Xcode. And the nice thing is that Kotlin is built, comes with native support for frameworks. So and I encourage you to watch the talk later today about the state of Kotlin multi-platform, which is going to cover that, I think, in much more details. But you can generate a framework with Kotlin native. And once you have your framework, you can import that in Xcode. Well, there are basically two ways to import that in Xcode. You can either make a big, huge monorepo with your Kotlin files and your Swift files and a custom build phase in Xcode that will compile your framework. You can also use Cocoa pods. So Kotlin native comes with Cocoa pod support, so it can write a pod spec that you can import in Xcode later. Both these approaches are somewhat similar in that they require you to build the framework on your developer machine, which has a few inconveniences. It takes time, and also it forces everyone in the team to have Java installed on their developer machine. So something that I'm hoping to see a bit more used is hosting compiled binaries. So like we have Maven repos, for an example. I mean, why not do that for compiled Kotlin frameworks? This would, of course, require versioning, but this would remove the pain of having to build your framework all the time when you change something. And when I say building is expensive, it is quite expensive. So on HS Tracker, which is not a huge Kotlin framework. Recompiling and linking the framework to something between 2 and 3 minutes, and this is every time you change one line, so it's nowhere near the instant evaluation cycles that you have with Fleur or stuff like that. It can really become a pain in the long run, and even in the short run, actually. And in the end, it's working. It's actually working quite well. You can import your framework in Xcode, call your Kotlin class. So this is a small Kotlin class I made for the purpose of the demonstration. It's just going to take one argument, which is a string, another argument, which is a count, and it's going to output a new string, which is a greeting, and it's going to say, hello everywhere, hello everyone, everyone. So it's working well. I mean, no worries there. You can even debug. So this was actually pretty cool. I didn't expect that to work that well. It's not as well integrated as with Swift, but you can put breakpoints in Kotlin files, provided you know a bit of LLDB. So that's the catch. You cannot just put something, click in the gutter here and have everything in the UI, and Xcode will not recognize that. But if you're familiar with LLDB syntax, you can do everything with the LLDB command line. So put a breakpoint here in your file, and when the breakpoint is hit, Xcode will open the file, and you can evaluate local variables. So for primitive variables, you can see that the count here is 2. You can try to display the name, which is a string, and you will end up with something like this. Oh, wow, what is this? So this is a pointer to what I was talking earlier, a runtime type called obj header, which is something from the Kotlin native runtime that describes a string, because a string is an object, so it has methods and everything. So it cannot be just a null-terminated UTF-8 character string. It has to be more, right? So yeah, you can try to dereference that pointer. It's going to complain. And if you want to take debugging a step further, Kotlin Native has a few built-in helpers for you. One of them is Conan debug print, which you can call on name. And it's going to give you a string representation of the object. So this is nice. You might want to debug in production. I know we don't want to, and we shouldn't, but life is what it is, and crashes in production do happen. And if you do not pay attention, since most of the crash trackers there do not know about Kotlin, you will end up with all the Kotlin crashes in the same stack trace, which is a shame. So you will see this Conan abort, which is not cool. And what you want instead is a nice stack trace. So thankfully, a company called TouchLab, which is doing a lot of very interesting stuff on Kotlin Native, developed this crash key iOS library that you can enable, and then you will have access to the full stack trace. Last point, when it comes to tooling, you can also do everything inside Android Studio or AppCode, if you prefer. There's a plugin called KMM that is released by JetBrains a couple of months ago. I think it was in October, so it's relatively new. But with this, you can do everything inside Android Studio, which is nice. A few words about the memory model, and I'm going to finish the Kotlin native part with this. The memory model is it's a big part of what the Kotlin runtime is, and it's also a lot of the pain of developing for Kotlin native at the moment. All this Turing machine, and I'm going back to the analogy about Turing machines, a lot of what they do is manage memories. So if you look at the JVM, there's a lot of effort that has been spent on optimizing the garbage collector, and there's a lot of work on the garbage collector. On the Swift side and Objective-C, you have automatic reference counting, which is nice, but puts a lot of work on the developer because you have to handle cycles. And if you want to avoid memory leaks, you have to deal with weak pointers and that kind of things. So JetBrains, being a developer-first company, they didn't want developers to worry about cycles. So they implemented something in the Kotlin native that does reference counting with an additional cycle detector. I'm guessing the implementation was quite complex because there have been a few memory leaks for some times. And when it comes to multi-threading, they enforced a new way of looking at things, which is called mutable XOR global. So it's a lot of very complicated words to say that when you want to access an object from multiple threads, you should make it immutable. And it's no problem to read from different threads. And since Kotlin puts a focus on immutability and functional programming, I think it kind of makes sense to enforce that. What that means in practice is that if you create an object, let's call it counter here, and try to change it from another thread, you will end up with this not very nice error saying well, incorrect dereference exception. That's not cool. So you have to call freeze first, but if you call freeze, of course, you cannot call increment after that. So this really forces you to change the way you think about multi-threading programming. And I think ultimately the community wasn't ready for that. There's a lot of talks about it. You can, like Touch Labs did a lot of advocating about it. So there's a lot of very nice talks about this from Touch Lab. But ultimately, I think JetBrains realized that if they wanted developers to adopt Kotlin native more, they should make it easier to use and not ask every developer to change the way they think about multi-threading. So they wrote a few, maybe 1 month ago, a bit more now, maybe 2 months ago, this blog post about memory management, saying that they will rework the garbage collector of Kotlin native to make it easier to work with in multi-threaded environment. And I want to take a pause here to recognize Salomon, which made a talk just before mine, actually, this morning, who predicted this a bit more than 1 year ago. So it's not often that you get to be right in the industry and predict something that will happen. So yeah, congrats Salomon. And I'm looking forward to see what JetBrains comes with. To wrap things up, Kotlin native is a very nice way to share your business logic. So you can continue writing your UI with Swift UI and sharing everything. Like if you have parsers like Tracker, the companion Earthstone app I was mentioning earlier, he does a lot of things with parsing log files to get the game state and stuff like this. This is a lot of parsing. This is stuff that is not linked to the UI. It's 100% business logic. And this makes a lot of sense. This is the stuff that makes a lot of sense to write in Kotlin. The ecosystem is ramping up really fast. Again, I encourage you to watch the talk later today about the state of multi-platform Kotlin. You have good solutions these days for a lot of stuff, like storage, HTTP networking, you name it. Only thing to be aware of is that, well, you will find some issues and like productivity might not be there yet, debugging and build speed, especially build speed is a big issue in my opinion. Now, let's come to the second part of this talk, and this is about another thing, which is quite new. It's called Compose Desktop. So this wasn't originally part of the talk, but since we are at Everywhere event, and the goal of Compose Desktop is to write UIs everywhere, I felt like it was worth a mention. So you can ask, what is Compose? So Compose is a Swift UI of Android. It's developed by Google. It's a reactive UI framework, like it's inspired, and it makes no secret about that. It's strongly inspired by Flutter and React. It's 100% Kotlin, and it actually uses a Kotlin compiler plugin to change the generated bytecode and to achieve observable trees. So you can think of your UI as a big series of elements that you can change and have a single source of truth. Well, it's not the topic of this talk. You will find a lot of talks about reactive UIs. The important thing is that it's the same thing for Android and now for desktop. It's working like this. So you have composables, which are basic building blocks of your UIs. There are functions, and the Kotlin compiler plugin will detect this and create your tree and update it when needed. This is the course. Not going to spend more time there. The important thing to know is that this works. And the thing with Compose Desktop is that it's not a Google initiative. It was developed by JetBrains. So while Compose is mainly for Android, what JetBrains did is take that and made this work with Windows, macOS, and Linux, which is cool. So if you're an Android developer, you can easily create an app for Windows, macOS, and Linux. Compose Desktop even allows you to write installers, so it's easy to distribute your app. It's currently at milestone 1, which means you need the latest IntelliJ version. I don't really know what milestone 1 is, but from what I've tried, it's working really well, and I haven't had any issue. So I wouldn't recommend using it in production, of course, but honestly, it looks pretty good. Under the hood, it's using Skia, which is a rendering library, and Skiko, which are binding for Kotlin. And to interact with the desktop, it uses AWT, which is really old technology. I don't know, it's maybe 20 years old. And AWT uses everything for Windows notification, system tray, and so on. Of course, what this means is that it's 100% JVM based. So if you want to distribute your app, you either have to ask your people to install a JVM or bundle the JVM inside the installer. It's working. So this is a window of my environment. So this is running on my Mac. It's working really well. And the feedback cycle is very fast here because you can recompile, and it doesn't take that long, and rerun on your Mac, and it's working well. You can debug everything. So the developer experience is really, really good. A few drawbacks, it's only material design. I mean, mostly material design these days because it comes from Android. So if you want the Cocoa, I forgot the name of the look and feel for iOS and macOS widget, Cupertino. So you will not find the Cupertino styles there like you would do on Flutter or stuff like this. And it might work on the web one day. Wrap up of everything after talking a bit about Kotlin native and Compose Desktop. There are a lot of options to use Kotlin on macOS and iOS devices. I would say you can go with Kotlin native for shared business logic and write UIs in SwiftUI or Jetpack Compose if you need native look and feel. If you don't care of having the same look and feel all platform, Compose Desktop is really interesting because it's really everywhere. I mean, it's truly multi-platform, compiled once, run everywhere UI software. And if you want the native look and feel, of course, SwiftUI is the best solution. I think that's it for me. So thanks a lot for watching, and I will go back to the chat for questions. I was a bit long actually, so the next talk will start right now. Actually, maybe I can go back to my flat. Yeah, I can go back to my flat. I love this thing. So if there are not any questions, I'm going to say thank you. Have a great conference. If you have any question, find me on Twitter, find me on the Kotlin Slack. You can find me online in a lot of places. I will definitely share the slides. I don't know what. I think the platform has something to share the slides, so I will upload there like as soon as I close this tab. So thanks again, everyone. Have a nice day. Have a nice Friday, and see you soon.